Yeah, we are
Yeah,
live.
we are live. We are live on YouTube.
Yeah.
And you want me to send the link to the YouTube session?
Yeah.
Okay. Tac, 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 tac. Okay.
Matt was telling me
Mm-hmm.
that even Docker guys confess that they are currently using Kubernetes as opposed to Docker.
Mm-hmm.
Yeah,
Even,
he was.
sorry?
Currently, even Docker guys have confessed that they're using Kubernetes instead of Docker Swarm.
Yes, Docker Swarm is not yes, it's a cluster technology, but it's a bit it's losing speed, and Kubernetes is gaining, yes.
Okay.
But I think that the only we could have started with Kubernetes, but I think that Docker is simpler to learn, and when you use Kubernetes, you need to know a bit about Docker. So
Yeah.
the reason why I do it like this. And when you use Kubernetes, the network, there is a network specific network layer, and it's not Swarm. Yes, Swarm is Docker launched a Swarm before Kubernetes was released, I think, and it's a bit maybe deprecated, but no, it's the right way to. And when you in the cloud, you can have Kubernetes as a service, and you can't have. I think you don't have anyone you can't find anyone who works with Swarm. So he is right when saying that Swarm is not interesting, but it's just because I think it's interesting to know more about Docker before diving into Kubernetes.
Okay. Yeah.
And I think that the other thing is that when it's building a Kubernetes cluster is still a bit difficult, and running Swarm is very simple. So that's it. Sorry, I didn't send you the link to YouTube channel. I send it on Slack.
Okay.
Okay, you got it.
Yep.
It's on
Thanks.
Premium Extra. Sorry, it's not.
Yeah, I got it.
Okay. Okay, and then we can go back to the sandbox environment. Okay, and I was in. So I was starting the cluster with swarm. Okay, and then I can cut and paste. Oh my god. No, it's not the. Sorry, no. My god, I've got to manager because I did some.
I keep getting data sum join requires exactly one argument.
Zut. Sorry. Sorry, Docker Swarm.
I don't know if you get the same.
No, I init a cluster Docker Swarm init minus advertise address hostname minus I, and then but the problem is that I don't know why I can't.
Copy?
Yes, surprise. Edit, copy. See, I can copy, but okay, edit, paste, and that's it. And then I join the cluster. So okay, the second. So you've got a manager on the first node and a worker on the second node. And then if you run no, it's on the sorry for you've got to run. So you can see leader, this node 1, and active on node 2. Okay.
Okay.
So on Docker node ls to verify that both nodes are part of the swarm. Okay. The ID. The ID and hostname values may be different in your lab. The important thing to check is that both nodes have joined the swarm and are ready and active. Okay. And the first node is the leader. Okay. So we switch. You do the step 2.
Yep.
Okay, we can share your screen.
Yeah. I think I was still struggling with this.
This one.
Step 1.
Sorry, I can share your screen.
So, so up here is where I need to run
Docker. Okay, it's okay. You run the. You just have to cut and paste the Docker swarm join.
Yeah, I think I already joined.
With the token, yes, you already joined.
So I need to do Docker. Okay, so that has like 2 nodes. And okay, so step 2, create overlay
Yes.
network. So now that you have a swarm initialized, it's time to create an overlay network. Create a new overlay network called overnet by running .network. So where do I create it? On the first node?
Yes, I think so.
So what does the -d flag stand for?
Docker network create minus d dash d. Don't know. We can look at this. Docker create network minus d.
Driver, okay.
Okay.
Yeah. So
Yes, you've
now,
got the bridge driver on the overlay driver. Okay. Um,
so we have overnet as well. The new overnet network is shown on the last line of the output above. Notice how it is associated with the overlay driver, and it's scoped. It's scoped to the entire swarm. Notice how it's associated with the overlay driver, and it's scoped to the entire swarm. So the other new networks were created automatically when the swarm cluster was created. Ingress and Docker GW bridge. So they say these ones were created immediately the swarm was created. So run the same command from the second terminal. Yep. So here we don't have like the overnet, but we have overlay. We don't have the overnet network. Notice that overnet network does not appear in the list. This is because Docker only extends overlay networks to hosts when they are needed. This is usually when a host runs a task from the service that is created on the network. We will see this shortly. So use Docker network inspect overnet command to view more details about the overnet. You will need to run this command from the first terminal. So this is Docker network. So we have so I think I wrote something wrong.
Docker network Inspect. Inspect PE, not EP.
Okay. Oh, okay. So name, ID, created, scope, driver is overlay, enable IPv6, false. Yeah. So this just tells us that we have the overnet network with the overlay driver created in the first terminal, but we still can't find it from the second terminal. Yes, you want to switch and drive on step 3. Okay.
Okay, step 3. Step 3. Now that we have a swarm initialized on an overlay network, it's time to create a service that uses the network. Execute the following command from the first terminal to create a new service called my service on the overnet network with 2 task replica. Okay. Docker service create my service network overnet replicas to Ubuntu sleep infinity. Okay, it's done, not done, nearly done. Starting, running. Waiting 3 seconds to verify. Service converged. Okay, so Docker service ls. Okay. The 2 in the replicas column shows that both tasks in the service are up and running. Verify that a single task replica is running on each of the 2 nodes in the swarm by running Docker service. So they say that you must as we ask for 2 instances of the service, we should find one on each node. Docker service ps my service. I did it here. Okay, Ubuntu latest node 1, node 2, node 1. And I'm not sure I can do it on the. Just trying, but I think it doesn't work. No, it doesn't work because there is no manager. Okay, so the ID and node values might be different in your output. The important thing to note is that each task replica is running on a different node. Now that the second node is running a task on the overnet network, it will be able to see the overnet network. Let's run Docker network ls from the second terminal to verify this. Docker network ls. Okay, you can see on the last line overnet, and then we can also run Docker network inspect overnet on this second terminal to get more detailed information about the overnet network and obtain the IP address of the task running on the second terminal. Okay. Oh, can you write Docker? Sorry. Docker Okay, we can mirror Docker network inspect over net. And yes, we got it. Docker network inspect over net. We can see it on the node 2. On the node 2, you should note that as of Docker 1.12, Docker network inspect only shows containers tasks running on the local node. This means that 10.10.003 is the IPv4 address of the container running on the second node. Make a note of this IP address for the next step. The IP address, the gateway is on .1 and the yes, it is my IP address is .42. Okay, containers, my service, blah blah blah, endpoint, MAC address, IPv4. Okay, so step 4, it's your time.
Yep. So I think I created the service on the first machine, and I was able to check that the service was created using Docker service ls. And at this point, we are doing like the 2 out of 2 shows both test service up and running. So it shows that the service is up and running in both.
Mm-hmm.
So we need to check that the service is running in both the terminals. So when I run this in terminal 1, Docker service ps my service. So that gives me something. But when I run it down here on terminal 2,
Now you Docker service is something that is attached to the manager, and the manager node is node 1. So when you run it on node 2, it doesn't work. I did the same thing.
so do I need to do like node?
Node 2 is a worker, and node 1 is a worker on a manager.
I don't understand. So I can do my
yes.
service.
The first node is manages the cluster.
The first node is the manager.
So
Yes.
you've got two types of nodes. You've got a manager and worker.
Yes.
The manager is monitoring and configuring this cluster, and the worker executes a container.
Mm-hmm.
And node 1 is both manager and worker, and node 2 is only worker. So when you try to run a Docker service PS on node 2, it doesn't work because you don't have the control part.
Oh, so that's expected. So how should I see that the service can be accessed from both? So I can do Docker network ls. Yeah, this thing. Oh, now we have overnet on this node.
Yes.
Then we can do Docker this thing scrolls. So it returns all these. So it has two peers. So you should note that as Docker 1.12, Docker network inspect only shows containers that's running from the local node. It means 10.0.0.13 is the IP address of the container running on the second node. So, okay. And then test the network. So to complete this step, you will need the IP address of this service task running node 2 that you saw in in the previous step. So I think for me, the IP address is this 10.0.0.4. So we have, I don't know where he read 10.0.0.3 from. So MAC address this containers. So inside the containers, and then that's the container ID, the IPv4 is 10.0.0.3. Mine is 10.0.0.4. So Docker network inspect overnet. So that will give us the IP address. And then notice that the IP address listed for the service task container is different to the IP address for the service task running the second node. Note that they are on the same overnet network. So run docker ps command to get the ID of the service task so that you can log it in your next steps. So docker ps docker ps gives that. So this is the okay. So then they tell me to log on to the service task. Be sure you use the ID from your environment, as it will be different from. So docker exec -it your container ID. I think this is my container. I'm not sure if I still should be running on the second container. Container ID. I can't copy this.
Yes, you just need to copy the first the five first character of the ID. I think it's like with Git.
Okay.
You don't need to copy.
So I should do docker
Exec -it.
-it. Bash. Yep. And then after I get into that, I should do apt-get update. So we also always need to install ping.
Mm-hmm.
I see they're installing ping.
Yes.
Yes, then now I should do ping. Should do ping minus C5 10.0.
Gateway.
Yeah, I can get I'm getting replies from that. And then now step 5. So the output above shows that both the tasks from my service and service are on the same overlay network, spanning both nodes, and that they can use this network to communicate. Okay. Back to you.
Yes. I'm looking at something that sorry, I can share my screen because I was wondering what the endpoint is, because when you look, sorry, it's not here. When you look here, when you do the when I do Docker network inspect overnet, okay, there are two IPs. There are three IPs. There is dot one is the gateway. Dot four is the container. Okay. And dot six is the endpoint. And I was wondering what is the endpoint is.
The overnet.
Blah blah blah. Maybe here can find something about that. Just looking. Yes, endpoint. To bypass, you can start the service. No, not here. Networking overview, maybe. Here. It's here. Endpoints. Manager, blah blah blah. Notice the post on endpoint. Yes, and then no. Just don't know what an endpoint is. Do you know what an endpoint is?
Not in this context.
uh, it's this endpoint. container network model, which is implemented by Docker Lib Network. There are three main components: sandboxes, endpoints, and network. Network sandbox, endpoint.
So it's like the container network communicates to the, why do they call it front end and back end? Looks like there's a link between the front end and the back end
I think
and the
it's
sandbox.
yes, it's an example. That will work controller object, the driver object, the network work in the air, it is configured. Okay, the network object. Some part of the was not in this guy represent the communication of the network. Do you understand what he's explaining?
Yeah,
Mm-hmm.
like I think I read that an endpoint connect, like, I think it's right there.
Mm-hmm.
It connects a sandbox to a network. Then an endpoint can belong to only one network and one sandbox. So it's like we have the sandbox where the container um, is running, and then we have the network that maybe links the outside of the container to the container.
Okay.
Non, non, faut ranger la chambre. Marie-Zélie, tu viens ranger. Non, mais c'est pas possible. Le bazar qui est dans la chambre, c'est juste pas possible. Ah oui, il faut aller se détacher avant.
I think that they say that Kubernetes is much simpler, but I'm not sure
Yeah.
that it helps us. So I get back to work because it's not, but it's always hard to understand things the first time you see them. Now that you have working service using an overlaid networks, let's test service discovery. We did it. No.
Yep. I think I did it on my.
I'm inside the container and I have to do cat slash etc/resolve. Okay. So this value sends all the values. It's okay. The value that we are interested in is the name server. This value sends all DNS queries from the container to an embedded DNS resolver running inside the container, listening on 127.0.0.11 port 53. All Docker containers run an embedded DNS server at this address. OK.
Alors, tu arrêtes de manger ton gilet, ça commence à te fatiguer sérieusement, là. Tu vas ranger les...
-C5 mile service. So I got it. OK. And then the output clearly shows that the container can ping the my service by name. Okay. Notice that the IP address returned is 10.0.0.2. In the next few steps, we'll verify that this address is a virtual IP assigned to the my service service. Type the exit command to leave. Okay. Exit. Inspect the configuration of the my service running Docker service. Inspect my service. Let's verify that the virtual IP value matches the value returned. Okay. Docker service inspect my service. And then you can see there is mod this virtual IP. Virtual IP is .2. Okay. Towards the bottom of the output, you will see the VIP, okay, of the service listed. The VIP, the output above is the 10.0.0.2, but the value may be different in your setup. The important point to note is that the VIP listed here matches the value returned by the ping -C5 my service command. Feel free to create a new Docker exec session to the service running on Node 2 and performing, or we can do it Docker PS, Docker service, Docker exec F409 sh -IT. No, minus, not minus. Okay, and then I have to do apt-get install. It is no, it's apt-get install. No, it's I don't remember the command to install ping.
Ping -C5?
In IP utils, yes. Up. apt-get apt-get install -y IP utils -ping. Okay, ping my service. Okay, it's .2, and then I'll let you do the cleaning up, and
Okay.
we are done.
Yeah. So cleaning up. So hopefully you are able to learn about a little about how Docker networking works during this lab. Let's clean up the service we created, the containers, and finally disable swarm mode. So we should here. So that was removed. Then we do Docker PS. Yep.
Yes.
This was it. So we're going to latest sleep infinity. So I'm not sure. Then Docker kill. So maybe that. Maybe I need to like Docker container ls.
I think when you kill the service, it kills the containers, but it takes time to kill the containers. It's the reason why when you do the Docker kill, you've got the containers. The container is still running at the beginning. Okay, I think so. I've got the same kind of. I get the same. Okay.
So this one Docker PS.
Because yes, but we don't have Nginx because we did these steps before like last time.
Yeah. So
we don't have to kill, and then you have to leave the container. You can begin on node 2. You can leave on node 2 first, and then on node 1, because node 2 is a worker, so you release the worker, and then you release but you can do what yes, Docker swarm leave without the force command. No, you don't need force because you are just a worker.
Okay.
Okay. And then you can force, I think if you have to force on the first one. You can try not to force, but I think it doesn't work. Docker swarm, leave, swarm.
So I need to force it.
Yes, you need the force. Okay.
Yep.
We got it. Congratulations.
Oh. Yeah. Wow.
Wow.
This was like a difficult lab. I think we should do it again sometime.
Or we may switch to, as you said before, to other resources about Docker. I think it's interesting to try many different ways.
Yes. Yes, I think that's gonna be great. Wow. Otherwise, I think it's great, and I think I enjoyed learning about networking, how you can bridge the networks or create an overlay between the two containers. Not exactly the two containers, but two nodes, the manager and the worker. And yeah, I think it was an interesting lesson.
Okay.
Yeah.
See you next week. Next week we can try to. I think there's something about orchestration. We have two Docker orchestration hands-on lab, part 1.
Mm-hmm.
The lab is longer than the other ones. Microservices architecture defined through a compose file. Okay. And part 2 is
Securing and operating Swarm.
I think that way, yes, they point an interesting point is that you can use compose and there is swarm. And swarm is, as you said at the beginning of the mob, swarm is a competitor of Kubernetes, but Kubernetes is maybe more interesting. And compose is something simpler, I think.
Yes.
Okay, and then there is a first lab about orchestration. We will begin with this one, and then join worker, deploy application. Okay, scale the application. I think we already did it a long time ago. No, do you remember?
Yeah,
This
I remember.
one. Yes, so we can skip it and go to the part 1. Okay. So see you.
Okay,
Have
see
a
you next
good
week.
day. Bye.
Bye.